Okay, you're most welcome once again to my YouTube channel. It is still your tutor Peter Ikaja as usual. And in this tutorial, I'm going to be talking about the continuation of integration and in particular, integration by parts. Before I get started with this, I would like to remind you as my viewer that you are supposed to have actually subscribed and turned on the notification button so that in case I post any other video, you are notified so that you keep following us. So I encourage you to do that so that you don't miss out in the next tutorials. Getting back to real business now, integration by parts. Now, one thing we need to know is that this kind of technique for integration has a particular formula that I will take you through. This formula starts from the derivative. So I will remind you that from the derivative with respect to x of uv, which is given as u dv dx plus v du dx, we can clearly say the derivative of uv is equals to u dv dx, then dx, I am multiplying through by this dx here, plus v du dx times dx. From here, I will now apply an integral sign on each of the terms so that we have integral of derivative of uv giving us the integral of u dv dx with respect to x plus integral of v du dx with respect to x. Now from this level, we need to know that when you integrate the derivative of uv, you get uv itself is equals to integral of u dv dx plus integral of v du dx. And then from here, we shall simply make this integral here the subject. So we shall now say it means in conclusion that integral of u dv dx, or with respect to x, is equals to uv minus integral of v du dx with respect to x. So clearly we can conclude that this is the formula we are always going to use for integration by parts. And it's important that we highlight it, as you can see it here, so that you can easily have it in your memory. So as you're reading this part, definitely you must give a lot of attention to this formula. Now, we can begin breaking down a few examples that would expect us to apply this technique of integration. Let's look at the examples. I will begin with the very simplest. Particularly, I can say find integral of, let me say x, natural log of x, dx. When you look at this integral, for you to begin doing it using integration by parts, I'm going to first help out with what we call the memory aid. I'm going to call it a memory aid. To aid you always find it easy, or to help you find it easy when using this technique, I have a word here called Layate. and you need to know the meaning of each of the letters. The first one represents a logarithmic function. Logarithmic function, that's the short form of function. This is an inverse trigonometrical function. A is an algebraic function. An algebraic function. T is a trigonometrical function. And finally, E is an exponential function. Exponential function. Now, the most important thing is knowing that we are going to be making two choices. One of the choices is we shall ask ourselves, what do we call U to be? And then what shall we call the VDX to be? Those are the two choices we shall be making under integration by parts. Now, using this formula, U becomes the first letter, or the letter that comes first. The letter that comes first. The letter that comes first. So that is what you need to know. And that means the VDX becomes the other function. Remember, each letter here represents a given function. Now, getting back to our question. When you look at x, x is an algebraic function. When you look at ln x, that is a logarithmic function. So we look at algebraic and logarithmic. Which letter comes first? It is definitely logarithmic. That means I will say in our solution that we let u to be natural log of x. Once you let u to be ln of x, that means you have to look for du dx by differentiating it. So du dx definitely here becomes 1 over x. And then it means now the v dx becomes x, which is the algebraic function. Now, if the v dx becomes x, our interest is getting the value of v. Now, for as long as you know the v dx is equals to x, it means for you to get v, you simply integrate x with respect to x. So our v will definitely be the integral of x with respect to x, which is supposed to be x squared divided by 2. After you making these clear choices, you now simply go and do the substitution in the formula. Remember we said from our formula, let me write it aside here, just to recall what we started with. We said integral of u dv dx is equals to uv minus integral of v du dx. That's what we started with. So I'm going to follow this formula and continue with my question. So I will now say it means our integral of u, but remember our u was ln x, if you remember very well. Our v became x, our dv dx became x dx. This becomes uv, but our u clearly, we already said it is ln x. We got v as x squared out of 2. I prefer writing it in that position, minus integral v, but our v is x squared divided by 2, and then du dx. We differentiated ln x, and we got du dx as 1 over x. So I have 1 over x here. All this with respect to x. So at the end of the day, we shall have x squared out of 2 natural log of x minus, when you simplify this expression carefully, you will have x out of 2 dx. And remember, half is just a constant, can move out of the integral sign, so that we have the final answer as x squared out of 2 natural log of x minus a half which is our constant. When you integrate x with respect to x, you get x squared out of 2, and then plus our constant of integration. That means we can conclude that our integral of x, natural log of x dx, is actually equals to x squared out of 2 natural log of x. I can say minus a quarter x squared, and then plus a constant of integration. And that is our answer for that particular question. So let's look at number 2. Number 2, we can even have a simplified form. They can tell us to simplify integral of ln x with respect to x. One thing you only need to know here is that this time around, our algebraic function is not clearly seen, but you need to know that we have ln x, but then there is a silent 1. That one is as good as x power 0, and therefore we shall treat it as if it is an algebraic function. So when you're letting u to be ln x, again, it means du dx will still remain as 1 over x. But then dv dx this time around will actually be the algebraic function that in this case we just have a constant, which is 1. So it implies that for you to get v, you integrate 1 with respect to x, and that gives us x. And therefore, our integral of ln x with respect to x is equals to uv. We're using the formula. Our u is ln x. V has just become x minus integral of v, which is x, and then the u dx, we got 1 over x with respect to x. At the end of the day, our answer becomes x ln of x minus, when you have x multiplied by 1 over x, the x cancels, so you remain with integral of 1 with respect to x, and therefore we can conclude that indeed integral of ln x with respect to x is actually equals to x ln of x minus ln of x minus x. When you integrate 1 with respect to x, you get x, and then plus our arbitrary constant of integration. As simple as that. We can also look at example number 3, but in this tutorial, I will limit myself so much to functions of a natural log, appearing, and then an algebraic function. Then in the next tutorial, I will also look at other forms, but which require the same method. Okay, so our number 3 gives us the integral of x log base 5x with respect to x. Now, one thing to be very careful about, for as long as the base is not base e, we are supposed to first change the base from what is given to base e before we apply our normal integration by parts. So I will first begin by sorting this question out by saying that integral of x log base 5 of x with respect to x is actually equals to integral of x. I'm now going to change this base from base 5 to base e. So it will be log base e of x divided by log base e of 5, and then with respect to x. From there, I can now modify this expression by simply saying 1 over log base e of 5 is actually a constant, so you can pull it out of the integral sign, so that I have 1 out of, I can even decide to write it as ln 5 now. So 1 over ln 5 is now a constant. We remain with integral of x, and then log base e of x is just as good as natural log of x. Don't get worried about that. Then from there, we definitely integrate our x ln x with respect to x. But then in this very tutorial, in our question 2, I already talked about the integral of x ln x with respect to x. Actually, it's question 1. Question 1, that's where we started from. So you needed to know how to look at question 1 well and then analyze it and understand. So here, I would prefer that when we refer back to our question 1 where we started from, our final answer was this. It was x squared out of 2 ln x minus a quarter x squared plus c. So you will allow me to quote this because now the whole procedure remains the same. The whole procedure remains the same. Only that you keep in mind your constant, which is 1 over ln 5, and that constant must be multiplied by it. So I will say that my answer here is going to be 1 over ln 5. This integral was already done in question 1. So I will say into brackets, we had there x squared out of 2 ln of x, and then we had minus x squared out of 4, or we can say a quarter x squared, and then plus a what? Plus a constant. So all this plus our arbitrary constant of integration. Remember, I have referred you clearly that this result that we have here was obtained from question 1 by integrating x ln x using the normal procedure. So you refer to number 1, and then you follow the same procedure to come up with this result. So this will be our first discussion on integration by parts. In the next tutorial, I promise you to now bring in other forms of integrals. Don't forget to subscribe. Don't forget to turn on the notification button so that you are always alerted when I post the next video for you to follow up continuously. I will now give some simple questions for you to try, and then we call it a tutorial for today. And there it is. See you in our next tutorial for the continuation of other forms of functions that we can integrate using integration by parts. Bye-bye.